Yeah, today I'll discuss in detail about the retrieval augmented generation and that we call as a RAG system. Okay, so let's see what is RAG and how it works. So before going for RAG, so basically what is how LLM works that we already seen. Okay, and what are the limitations of LLM? Okay, let's see limitation of LLM. Let's take a scenario, any scenario. So here I'm taking one simple scenario where we are going to build a chatbot for an organization. That could be any organization. Okay, we using LLM. Chatbot with LLM for an organization. Organization means it's having its own information, its own data. Okay, and that chatbot can handle general language understanding like asking questions, normal natural language type of interaction. Okay, and it generates some well structured answers. That is the scenario I'm taking. Mostly all LLM based applications are like this. Now when we ask some question, any questions, here I'm trying to ask question, what is the leave policy and how many leaves will be added for a new employee? That is the question. Okay, let's so what you will get, immediately you will get some answer, right? You guys are observed that LLM will give, whenever you are giving a prompt, immediately you will get a response. Let's take the same thing for chat GPT. So I'll ask here let's assume chat GPT we are going to use here. What is the leave policy? I'm asking here for chat GPT policy and how many leaves will be added to the new employee. This is a question. When I am giving this question, see, I got immediate response, right? So this so we got the same immediate response. So it is not asking any questions, but it is giving immediate response. This is the problem with LLM. Okay, if it is not clear, if ChatGPT or any LLM application is not clear, it should ask, right? So which organization you are talking about, that kind of thing. But without asking that, it is giving a response. Okay, so that is the problem with the current general LLMs. So that is because it was trained only on available data and at a certain period of time. It's not a future date, it's a until some date, it's a fixed date, and it's trained on available data. Here available is public data. Okay, so and it is not having access to any private information like any company's information, and it just generates basing on patterns. So this LLM basically works on basing on a pattern. What is the next word it's going to get? It's completely basing on patterns and not verified based on facts. Okay, so this is the problem. So that's why, so if say generalize those things, those limitations, yeah, LLMs have a static knowledge. Okay, static. Now I'll explain this one with the real-time use case. And they can't access a private or company specific information. Okay, that will call as a proprietary data, and it's a lack of source of the information. Okay, so it's a lack of source of information, and so this is obviously poor alignment with the internal data, because we have internal data. So each company is having its own format, right? Each company is having, let's say, each company is having its own coding standards. So one company coding standards may not be same with other coding standards with other company. Some companies maybe have a coding coverage code coverage of unit test maybe 80%, some companies will have 90%, some companies will have a 60%. Okay, so each company is having its own format all the time, so this is not aligned with that format. Okay, so these are things. So let's take this one with a real-time example. LLMs have a static knowledge. Let's take this one. So this LLM is something like our qualification. Okay, let's say you are qualified as a developer. Let's take a developer. Okay, so let's say you are a front-end developer, maybe Android developer. Okay, Android developer is a general thing, right? That's a general knowledge for an Android developer. That is a common mobile app related concepts are common. But when you are working with a company, so company is having some specific tools to develop an Android app. Okay, if you are iOS developer, iOS is a general thing, that's a static data. Okay, so when you are working with the company is also developing iOS application, but it is having its own rules and regulations, patterns thing. Okay, this is a kind of thing. Are you getting? You guys are following? Okay, yeah. So these are the limitations. So basically, LLM will generate a static data, and it's no source of that, and it's generic information. Okay, so to overcome all these things, we have a RAG. Okay, retrieval augmented generation. Let's see. So basically, RAG adds a retrieval layer between a user query and the LLM. So user query here is basically prompt. So instead of sending a prompt directly to the LLM, we'll pass the query via RAG system. Okay, that is a thing. So here let's take retrieve is basically finding domain specific information. This is the key here. We are retrieving domain specific information from the so from where, that is the question here. Okay, so basically retrieving domain specific information from somewhere, that we are going to see. After retrieving that information, so we are passing that retrieved information along with the prompt to the LLM. Okay, so that is called augmentation. Augmentation is basically adding some extra information or some features, that kind of thing. That is called augment in dictionary meaning. Okay, so prompt is the one we are adding retrieved information that is domain specific to that particular prompt. We are augmenting that, and then we are passing it to the LLM. So LLM will generate the final answer depending upon the prompt and domain specific information. Okay, so here whatever the domain specific information we are passing, right, that is actually fact. We are taking from a legitimate documents. Okay, so that's why we are having, that's what we call as a factual context. That information whatever retrieved, right, that is actually factual content, that is a source for the LLM. So this RAG is basically two-step process. So normally if you see all of internet, right, nobody mentioned about this two-step process. They'll explain the RAG, but so I'm trying to make it simple. So this is basically two-step process. One is basically we are going to create a knowledge base, and after creating a knowledge base, that I'll explain what is knowledge base in the next session. Okay, sorry, next slides are coming forward. And that is first step, and the second step is retrieval from the knowledge base. That is what first point, retrieve, finding a domain specific information. That domain specific information we retrieve from knowledge base. Okay, from knowledge base we retrieve that domain specific data, and that is a source for that one, and we'll pass it to LLM. Okay, Let's take a simple LLM app flow. Let's any regular app is basically, so user will send a prompt to the LLM and LLM will respond back. This is a regular thing. Let's say ChatGPT. ChatGPT is kind of this one. We give the prompt and directly it will go to the LLM and we'll get the response. This is a simple way. Whereas if you see RAG based application, the flow is basically it's having a user and LLM and we have a RAG component. Okay, if you see the first point here, it's a RAG adds extra layer. Okay, that is a RAG thing. So the flow is, so user input will go to the RAG system. RAG system will get the domain specific information and RAG system will pass that information to the LLM. Prompt plus augmentation. That augmentation is basically retrieved information. Okay. So the basing on this one, LLM will generate the response and it will pass it back to the user. This is the RAG based system in high level, very high level this thing. Okay. So let's take the benefits of RAG. So here, what are the benefits? Why we are going for RAG? So first thing is it reduces hallucination. Hallucination is basically it's not a, it's kind of fictional thing generated basing on some data. So instead of that, we are passing factual information. So response will be based on that factual data. So there are no assumptions, anything like that. And it enables domain specific personalization. That is basically domain specific content. Let's say the code coverage thing. If your company is following 80% code coverage, and you'll get the information related to 80% code coverage thing. And if your company is following 70% code coverage, you'll get the similar to 70% code coverage answers. Okay. And it provides source, because we are passing factual context, we are passing that, and it is having a document references, so it also provides source of the information. Okay, so and it's a more like a lightweight, because we are not retraining it, we are just passing the information. That's why it's kind of lightweight for this thing. And you can also get the updated such as feature date, so it's not a cutoff date. There is no cutoff date if you use the RAG. Anytime you can update the RAG system and you can get the documents or information. Any questions here? You guys are following? Okay, yeah. Let's take, because I told this is a two-step process, right? Yeah, this always making a problem for me. This is a two-step process, I told you, right? So let's take first process, that is basically knowledge base building process. So here, so in knowledge base, so there's a flow. Basically we need to collect external data sources. Okay, after collecting external data sources, we need to load the documents. After loading the documents, I'll explain all these blocks in detail. So initially I'm giving complete flow, then I'll explain each one. After loading the documents, this will give documents, a list of documents. Okay, that list of documents will pass it to chunking, that is basically splitting the data into small parts. After that, we'll create embeddings. Okay, so that embeddings are vectorization or this thing. After embedding, we'll store that in a knowledge base. So the final result is a knowledge base. Okay, that knowledge base normally we'll store in a vector database. Okay, this is how so knowledge base is created. Let's take one by one. So what are external data sources? That external data sources could be anything, any documents. So that we'll call as a data resource. Okay, that could be structured, unstructured, any kind of data. that is specific to your organization or specific to the company. Okay, so organization specific are domain documents like PDFs, manuals, articles, database, okay, helping documents, facts, internal policies, anything. Okay, so these documents, all the external things we will call as a external data sources. So these external data sources provide real time. Here the real time means up to date. Okay, real time means up to date. And domain specific information, so that is not part of LLM's original training data. Okay, so those things we call as external data source. This data source we can so we need to make, because we have a different formats, right? So basically PDFs will have a different format, okay, database will have a different format, web pages will have different format, markdown files will have a different format. Okay, so by loading those documents we are making all in a standard form to process. That is where this load documents stage. So it basically read and import external data. Okay, so these things after loading it will process it, will give a list of document objects. See, the list of document objects, these document objects are structure is same for all the external sources, like whether it's a PDF, text file, web pages, database, markdown. So it written a standard document object format. Okay, so here we have a PDF, a different data format, right? So to make the standard document object format, each is having its own loading methods. For loading PDFs we have a PyPDF loader. So for folders, files, all those things, directory loader. Web pages we have web page loader, like that. Okay, so this is the thing, it basically makes all the external resource in a standard format to process. Okay, so after loading these documents, we'll have a final list of document objects. These list of augments so will be splitted into chunks. So basically the chunks is the process of breaking large documents into smaller manageable chunks, because small parts, basically partitioning. So smaller chunks allow the retriever to find highly relevant information or sections, highly relevant sections. Okay, so why we are chunking? So basically LLMs have a limited context window. That limited context window is basically token limitation. Okay, so sending smaller chunks of data to the model will get a more relevant information and it will not exceed the token size. Okay, so that's why we are splitting into chunks. And smaller chunks reduce embedding computation. Okay, this basically I'll explain embedding, what is embedding here. Okay, the splitting of chunks, right? So basically we need to follow some chunk overlapping. So that chunk overlapping is basically that is small repeated segments between chunks. Let's say there are 10 points. 10 points, if you want to chunk it, let's say 1 2 3 4 5 6 7 8 9 10. If you want to split into chunks, first chunk is 1 2 3. Okay, and the second chunk should be 3 4 5. Okay, 3 is overlapping here, so that is a kind of overlapping. You're getting my point, right? Overlapping, guys, can you respond? Okay, yeah, that is how we'll see. So chunking is basically splitting a data. Let's say the data is 10 points, the sequence of numbers 1 2 3 4 5 6 7 until 10. Whenever splitting into chunks, so first chunk, example I am giving, it may not be like that, example I am giving. So 1 2 3 is a first chunk, second chunk should be 3 4 5. Okay, Here if you see first chunk and second chunk, 3 is overlapping. In first chunk is 1 2 3, second chunk should start from 3 4 5, and third chunk should start from 5 6 7. Okay, so 3 is overlapping and 5 is overlapping, like that, so that we'll have a relative information, like so we'll not miss the link, that kind of thing. Okay, that's why we should have a overlapping. After chunking the data, the chunking is basically splitting into small parts. We'll go to embeddings. So embeddings are a numerical vector representation of text. I think that I already explained in our previous sessions, but anyway, so it's a numerical representation of text. So it is basically retrieves to find relevant information. That relevant information is based on a meaning is semantic meaning, not just a keyword matching. Okay, so converting into vectors will help to efficiently retrieve and store the data from vector database. That's why we are converting into embeddings. Embeddings are vectors. So here retrieving basically semantically similar chunks. Let's say if you want to retrieve the leave policy. So leave policy, if you have a multiple documents, right, you have hundreds, let's say 100 documents are there. In that maybe 2-3 documents referring to leave policy. So this thing will retrieve leave policy from these 3 documents. Okay, based on a contextual, that contextual is basically semantic meaning. Okay, context sensitive, I told you, right, that's a semantic meaning. That is called embeddings. After creating embeddings, that will store in the database, vector database, that we will call a generic word is knowledge base. Okay, that knowledge base is could be structured or unstructured storage of information. Okay, it acts as a source of the truth. See here the thing, that is the limitation is LLM is not providing source, right? Here we are providing source. So normally vector database is used to store the knowledge base in the form of embeddings. Knowledge base is a generic term, so storing that information is vector DB. So some of the vector DBs are Pinecone, so Fies and Chroma, Milvus, many things, but these are the popular ones. Any questions here? You're clear? Yeah, so this is also an LLM only. You are going to develop LLM applications, right? So but this is a process where LLM we need to pass the input prompt. Okay, so we need to specify specific input. Okay, that specific input we are generating using this process. We need to do that. So let's say so we as a developer we need to do this. Okay, so let's say in your organization now everybody is see, if you see Confluence, you heard about Confluence, right? All the companies having Confluence pages. That's actually a document. It's having lot of information. How to do that? So let's say if you want to normally what I will do in our company, if I face any issue, first I will search in the Confluence page. Normally we will have that history and all the stuff. Most of the time we will get that. Okay, so but that Confluence will work based on keywords. So now, so you have a Confluence page, you can generate a knowledge base, and you can have a separate UI. Okay, kind of ChatGPT kind of UI. Instead of pasting your error, you can type, hey, I am getting this error, is there any solution? Then that from knowledge base you can get the reference. That is one kind of use case. Okay. What do you mean by web service? Can you give me an example? Okay, that is a prompt. Okay. Okay, so in that, see, how many leaves a employee have is not a valid question. Let me rephrase this. How many leaves Gauri have is the question. Okay, or what is the leave policy is the question. Okay, so it's not like how many leaves employee have. That's not see. So number of leaves depends on employee, right? It's not a generic thing. Okay, so your phrase should be either how many leaves Gauri is remaining, the question, or how many leaves a new employee can get is the thing. These two are valid things, you're getting. So here, how many leaves Gauri is remaining is specific to Gauri. Okay, that is not a generic information. For that, you need to make a call, API call, to get the information, because it's regularly updating, right? So that you should make a API call. For that, you need to use MCP server. Okay, so whereas generic information, that is a document. Okay, how many leaves a new employee can get. Okay, all right, no, that is a document, that's a knowledge, that's a document, right? So in that scenario, you'll use this RAG system. Whereas if it is specific to the employee, or specific to the resource, we need to go for API calls. Okay, if it is a knowledge base is generic thing, it's not a specific. Okay, that's why we are referring as a knowledge base. Knowledge is always generic, we cannot say that specific. Okay. Yeah, any questions, guys? Others, you are following, or is it too technical or too detailed? Can you guys respond? Okay, okay, fine. Yeah, so this is step one. Basically, we created a knowledge base. Then the next step is retrieval process, basically. Okay, let's see. So we created a knowledge base by seeing this process. After that, a user or customer is one thing. You will send a prompt, and they'll send a prompt to the LLM application. So because that is what it's handling, and LLM application will send a request to LLM. These are the components involved. Let's see the flow here. So user will send a input prompt to the LLM app. The LLM app, so basically what it will do, depending upon the prompt, it will go to the knowledge base. Okay, so on that knowledge base processor, it will not go to the knowledge base, it will go to the embedding step. First, it will convert your input prompt to embeddings. That's a bit vectorization. Convert into numerical number values. Okay, that will get that done. We'll get the numerical embeddings. That numerical embedding will go to the knowledge base. Okay, sending those embeddings to knowledge base to get a similarity search. So basing on a similarity search, we'll get, so that knowledge base is basically having chunks of data, right? We stored that, so we'll get the chunks of data. That chunks of data is a contextual information for us. That is a actual data, we got it, and this information we will pass to the LLM. So sending prompt and data from knowledge base, both will send to the LLM, and LLM will generate the response, and that response will pass it back to the user. This is the actual process. If any RAG system is thing, right, this is how it is going to work. Okay, so is it clear? Yeah, so maybe before going for limitations, maybe I'll show the demo, then we'll go for limitations. Okay, or maybe if you want to, anyway, let's complete limitations, then we'll see. No, I don't think limitations will understand without seeing that. Let's see. I'll show the demo. Mm, I created. I'll compare both things without LLM, without RAG is one application. I created two to compare everything, P3 LLM with RAG. Okay, so I created two applications. One is without RAG system, we are interacting with the LLM. Okay, we just give a prompt and LLM will give the response. Is one application. And another application, I created a RAG application. So basically it followed all the steps that I'll explain later, but I'll show it created 13 chunks, all the stuff. For that chunks, what I have given is, I have given two documents. Okay, one document is my resume, another document is Gen AI course syllabus. These are the two documents I have provided. Okay, so let's see without RAG what it will do. So I'm asking question, who is Chandu the dev. So Chandu the dev is my Git profile, and in social media everything technical thing, I use this word. It's internet, it is there, that's why I'm using that word. Okay, my profile in all the technical website, Git profile, that one. So I'm asking this question to LLM. I'm sending a input prompt directly to LLM. Let's see what it is going to give. Who is Chandu the dev? Okay, see here it is giving Chandu the dev is a popular Indian YouTuber and gaming content creator. See, it generated, it has given the information, and he is primarily known for his Free Fire something, whatever it is, but this is not completely related. I don't know about all this stuff. Okay, but it generated. This is the problem with the LLM. I don't know why it is giving like that. I don't like video games. It is giving, but somehow this is matching. Okay, except this Telugu, there is no relation with the information. This is called hallucination. It generates basing on some content available on this thing. Okay, now let's take the same question. No, it's I sent a message to LLM. This is LLM application. I given a prompt to Gemini LLM. Gemini, I use internally Gemini. Okay, so let me show you the code then, at least so you'll be getting that. Yeah. So anyway, this is the one. I'm using Gemini LLM model, and I'm asking this question, who is Chandu the dev? I got this information. This is not related to me. It generated. Okay. Yeah. LLM assumes lot of things, right? It assumed, depending upon my name, it assumed lot of things and it generated. Okay, so that's why there is no references, right? There is no source here. It just generated. Basing on what values it generated, we don't know. It just given the information. This is the problem with LLM. This is the actual use case. So now let's overcome this one. For that, I created a RAG based system. For that, I passed my CV, is one document in PDF format, and I also passed the course of this Gen AI related course. I prepared a syllabus and I passed this document. Okay, so let me ask a question here as well related to Gen AI syllabus. Is Gen AI course covers React JS as well, because I am going to ask same question on the RAG system. Let's see what it is going to give. because I prepared Gen AI course with some modules that I'll show in the next app. Okay. See, it's giving lot of information. So where is the question? Here is no. So generally, so it is giving generally no. Typically, Gen AI course will not cover React JS as a core topic. Here is why, because it's giving a general information, right? Because depending upon Gen AI, it assumes so React JS is not related to that, and it's giving a lot of information. Okay, this is all generic information. Let's take the same questions here. Because I passed two PDFs to this rack system, it generated a knowledge base. That okay, knowledge base I'll explain. So what vector base we used, we'll see later. So who is Chandu? Because I provided resume to this rack system. Basically, it is the see based on the context. Chandu Dave appears to be online handler. A username for Chandrasekhar Pasmati. Okay, this is indicated by his email. Chandu Dave GitHub is this one. Website is this one. Chandrasekhar is having professional with 10 years of experience. Blah 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 blah. Okay, this information I got from a because I passed my profile to rack system. It is there, right? Now you are getting the point. Yeah, so now let's say is Gen AI covers React.js course. See, no, the provided context does not mention React.js because context we are providing. Okay, skill card. You're clear? So maybe you can ask any questions. Let's say who is, yeah, right. It's clearly mentioning. See, so because agentic AI course syllabus I prepared, right? That is not having a React.js. Okay. So what is the give me the no, here Gen AI course I am asking. So let's say so now let's see. Ask the question because you are asking, right? So will is Chandu the dev have React JS skills? Right? This is what your intention, right? Now let's see what will happen. Yes, hands-on experience developing front-end web using React.js. This is what I mentioned in my profile. Let's say some specific not related to my skill. What will say is కొంచెం డిఫరెంట్ స్కిల్ చెప్పండి నాకు అర్థం నాన్ టెక్నికల్ థింగ్ no, I did not mention that the course doesn't have this React.js. That's why no, the provided because the provided context because it is retrieving from knowledge base. Okay, so there's some semantic basic and semantic information. It got some domain. Okay, that information is not having React.js. So that means my that course is not covers React.js. Okay, is Chandu the dev, or instead of Chandu the dev, Chandra, let's say is Chandra have .NET skills? Let's see what will happen. See, .NET speaker. I never worked on .NET, so I did not mention that in my profile. So this one, the provided context does not mention the. See here, it is clearly giving the provided context. This one we can because it's output text, right? We can modify that all the stuff. Yeah, let's see. Let's check. That's fine. We can check. Is Anand have .NET maybe have Java. Okay, Java skills. Yeah, we have application. You can try and test it. So there is no mention of the person named Anand. Okay, so this is big C because the information describes the course and the resume of Chandrasekhar Pasmarthi. Okay, therefore it's impossible to determine if Anand have Java skills from this context. No, see, it's not about getting answers, Gauri. It's about system. It's not about answers. The system. Okay. No, so it's so much data. See, company doesn't have so much data. For all those things, PDFs, right? Document doesn't have 10 GB. All the text, right? It doesn't have text, doesn't contain. So 10 GB is fine. Nowadays, we have a lot of. See, that's a knowledge. Creating knowledge base is a one-step process. It's an offline process. Okay? Processing 10 GB, 20 GB doesn't take much time nowadays, right? Yeah, so it doesn't take even 100 GB also doesn't take much time, and we are converting into vectors. The processing and storage will be less, and search will be very efficient. See, I worked in 2019. We created 1 million faces vector database, and the search was very fast. Okay, so maybe I got this one. Maybe I want to show that. So anyway, we got that. Let me show. I'll come to this one later. Yeah, this is the one I worked in 2019. Okay, so at that time we used vector embeddings. So that vector embeddings will get a similarity, right? Context meaning, semantic meaning. This is the one. These are all I worked for Indonesian bank, and the language is in local language, that is a Bahasa. Okay, the language is Bahasa, and if you see all the we I worked on a transaction classification where depending upon the transaction we need to classify that. At that time it was new. Now everybody's all bank apps are having that. At that time, to classify that we need to find semantics of that. So let's say if it is a food related thing, if you see here, see these are all coming to food area. IM is basically I think rice. Okay, tapas, kopi, these are food related information in Indonesian language. Okay, and if you see IMAX and cinema are more closely to the one. This is a vectorization. Whereas IM is a rice, it's a food related. Cinema and food is a distance. You see, there is a difference. Okay, this kind of thing. This is how vector database works. Okay, yeah. Here, any questions? Uh, mm-hmm. Right. Yes. It went for first document. Yes. Yeah, because see, I actually I did not print all those values when you are chunking, right? Okay, let's go to the code. Okay, so do you have any questions here? And then we'll go to the code. Mm-hmm, mm-hmm. Right. Yeah, that's one step process. Yes. Okay, so that's what first step is, we need to prepare a knowledge base, then we need to go for the H1. That's why I told you there's a two-step process. So that knowledge base, it's keep on updating, right? So normal, let's say policies, let's say like a leave policy, maybe after 2 years the leave policy may change, right? So that again we need to update the knowledge base with the same process. We already have some, it's kind of database, updating the database. You already have a database, and again you are adding new features to the database. Hmm. Mhm. Right. Yeah, that will be done by RAG system, because we are creating a knowledge base, right? So knowledge base process, if we go to knowledge base, let me, oh, how to stop this, man? Because if you stop this one, it may affect recording. That's why I'm here. This knowledge base, right? Here, first we are taking documents here. Documents basically file name, right? Those file names we are converting into standard format. It contains document name here. So that is we are chunking. That chunking is also get the chunk ID, document ID, page, all the stuff will get here. Okay, this embedding is only converting the text into embeddings, whereas in storing, right, we are storing the chunk ID, text, and the corresponding document ID. Everything will store here. When we are retrieving, basing on the vectors, we'll retrieve chunks of actual data, plain text, and document ID, chunk ID, everything will get. Okay, that is how we'll get a source, because we are passing. So in this document, this is a chunk, this is a page number, if you want. So normally we will not need that. If you really want, we can show that as well. Okay. Any more questions? Okay, so let's go to see. So here we're talking about embeddings, right? So chunking all depends on your see, this is generic information. Okay, so for loading the documents we have a lang chain, but in JavaScript you have some other thing. If other tool comes, you can use that, but the process is same. And regarding the data chunks, the process is same, but maybe tools will have a different thing. So like that, embeddings is also having a lot of different methods to, I mean different various companies are providing to create embeddings. Okay, each model will have its own embedding process. Gemini is having its own embedding method. Okay, and OpenAI is having its own, like that. So anything you can use, but I try to use Gemini because, but API is, it's not a free, so that's why I used a local thing. Okay, but so concept is same. Okay, yeah. So let's see the limitations also, then we'll go to the code. Yeah, so limitation of this thing, the data quality is the sorry, data quality is the one. So this RAG system purely depends on external documents. Okay, if the external documents are outdated, you will get the incorrect results. Okay, so you have to be very careful on the quality of the data. The same Gauri, you asked, right? So basing on quality data. And chunking strategy, this is very important, because we are splitting the documents in small parts. So that completely so the trial and error kind of thing. So how we are going to split it is the key thing. If it is a too large, so we'll get problem, and if it is too small, you'll get a problem. So it has to be so average. That will get basing on our understanding how document works, multiple iterations, all the stuff. Okay, if it is too large, you may miss context meaning. If it is too small, also will miss context meaning. Okay, security and privacy, this is the one of the reason. Okay, we have things, but still, if private sensitive data is indexed, basically if it is part of chunks. Okay, indexed is basically storing in the database, right? So if it is indexed, so there is a chance for exposing that sensitive information. So that's why we have to be careful while creating a knowledge base. Let's take a credit card number, that kind of thing, any sensitive information. And if you ask out of domain queries, that is what you're asking, right? If user asks a question that is not covered by external data sources, you'll get wrong results. And latency and cost, because basically we need to extra knowledge base processing, right? So that anyway needs some extra effort, and we need to get the information from rack system. That is what extra latency. Okay, so you guys are having any questions? Anything, yeah, images, any stuff. So but images normally it can, but image processing is different. LLM is basically text based process. Okay, so normally in companies will not have images basically. So PDF is also that one. PDF will read the text from PDF documents. Yeah, so but the process is same. If you want to create image based rack system, the process is same, but we have a different tools to process that. So whatever it is, whether it is a video, audio, text, or image, like finally when you are creating embeddings, right, that those are numerics. Okay. Mm-hmm. No, I'll tell you. Also, Copilot is a model, generic one. Okay. Mm-hmm. Then in that case, it's a rack system. See, normally, you check the URL of your Copilot, what you are using. That should be your company URL. Right. Because the UI looks regular Copilot. That's why they are saying that the Copilot. So basically, your company Copilot. That is basically the request directly goes to your company, not to LLM. Yeah, that's a rag. Yeah, that's a rag. Yeah, that's anything. If you are using any LLM application for your company, okay, that is a rag system. Because it's a company, right? They'll have a security policies, all the stuff. I think they should be following. I'm sure they should be following. Yeah. Okay. Mm, mm, mhm, mhm, mhm. Okay. So that is because, see, if it is a corporate thing, they they will not use a public URL. Okay, it's public model. They will have a company thing, corporate one. So that's a paid account. Okay. So if it is a paid account, always there is a limit. So that limit may be in your company, within your company, per user. Let's say there are 100 requests per day. And if you are having 10 employees, maybe they will split into 10 requests per candidate per day. That's the limit. That could that like that they will organize. Yeah, that's all. The developers who are integrated that RAG system. Right. Yeah, business requirements, and they will this all this limiting thing. All this it's not related to LLM app, right? It's a regular logic. Yeah. So yeah, no, number. Mm, 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 mm. In our company, we are using a Gemini model. Gemini model. So many even my manager also doesn't know, because every time if I after passing three requests, we are getting timeout. I mean exceeding the limit error. Every okay, and because it's a company, we nobody knows who is having the control on that. We got the credentials and we are using. That's the thing. So that's still in initial stages. People are working on that. So yeah, how to handle those kind of things. Yeah, data scientist కాదు. Data scientist basically, no. So they will work on data. Okay, like extracting features, which feature is good for a business purpose. Okay, that kind of information they will work. Uh, no, they can interact. They can interact, but they cannot develop. Okay, if they normally data science, the people what they will do, they'll get the information, they will get the data. Okay, that data they will clean it, all the stuff they will do. After that, by analyzing the data, they will try to fetch what features are good for business. Let's say the mobile application. So mobile application data, the statistics you provided. So from that, maybe they will try to get how many users are more in Asia, okay, how many users are there in US. By analyzing that, it seems that Asia are using more users, may spend more time, invest more on Asia side. These are the insights. These insights they will data scientists will get. Okay. Yeah, their job is that one, not these things. Understanding that data, understanding the domain. Okay, understanding the business. So that stuff. No, that can be no. That's no. We cannot do that with the RAG system. RAG system is basically giving a facility. Uh huh. No. Okay. Mm-hmm. No, see, that is thing. Yeah, we can. Let's say we have a data, we inserted into knowledge base, and we can ask in which area more users are using. That will get, because that thing is okay, but more business oriented thing may not get. Even though we are passing that, we may not get some of the business requirements. We may not get completely. Okay, so let's say how to invest, in which area we need to spend more time. Okay, that we need to discuss with the business team. Okay, getting the statistics, finding out decision making, that any AI system cannot take decisions. Okay, those kind of things scientists will do. Yeah. So it will give information, but More generic, more business oriented thing, any system cannot give, only humans can get. Yeah, yeah. Okay. Yeah. Okay then, Mary, do you guys having any questions? Okay. So if not, then I'll stop here. So maybe demo will see in the next session. Yeah. Okay. That's fine. We'll work out that. So you just ping me that. Yeah. Yeah, guys, you start working on this. So sessions are almost. So theoretically is almost done now. Okay. Mostly everything is going to be hands on. Okay, so we are going to develop 2 3 applications. One application is RAG, I showed you, right? I'll explain in detail line by line in the next session. After that we'll create one more chat gpt similar kind of app we'll develop. Okay, so that will have complete if you're not having knowledge hands on, right, so it may not get the point. So we try to work on those things and come up with questions. Okay. Yeah, I'll stop sharing.